Hello YouTube, De-bodgery here, aka Richard Gumpf on Facebook. Welcome to EV Components Review. On the bench, I have a QS165 I've taken apart. If you like my video content, please like, subscribe, leave comments below. All that stuff helps my channel grow. Anyway, yeah, you're going to now get to look at the cover pieces. There's going to be a little bit more that goes on in another video where I do things like measure the phase, inductance, and resistance, where I put a Gauss meter on here to measure the magnetic strength that you're getting here through the iron. I will also put this motor on an oscilloscope and spin it up so you can see the back EMF. Several things like that. As far as I can tell, is that this winding in here is 5 or 6 turns around every stator tooth. And and also talk about what the thickness of all the strands are too. But that'll come in another video. Anyway, let's look at the shell pieces. There is 2 versions of this motor before I do that. So this is obviously the pulley version, and I'm going to probably press fit this shaft out and get the splined version so I can use sprockets, because I like chains, I don't like belts. That's just me. You know, I'm going to do all 428 chain for everything. So yeah, that'll get changed. Anyway, the cover is 2 pieces, so this is the back piece, and this went over top of this end of the stator right here, and these 3 studs. The stator wires came up, went down over those, and then the phase wires, which are here, they then went in these little slots, and they went over those, and then a various and sundry sized brass washer went over top of that, and then a nut went on top of that to clamp it all together. These were all fairly tight. I had to use a 1/4" wrench to get them loose. So yeah, those are probably not going anywhere. And this cover right here, this was sealed down with silicone like that, and then it has 5 M4 screws in it to hold that in place. So that was fairly secure. The screws themselves were kind of odd. Yeah, so like that one right there. I don't know why you can see it on camera, but that's not me. I didn't do this. This controller this motor is brand new, and you can see how cammed out that head is. But yeah, I'm pretty sure some gorilla over at QS basically cranked on these screws too much and really buggered the slots in these Phillips head screws. Yeah, that's not my doing. Anyway, the underside of the cover, you can see the mill marks from the molding, you know, the original cast molding, and so this casting is done very early on in whatever steel molding this was. Over time, the castings, they get worn, and so you don't see the mill marks in them anymore. And this one is still pretty close to brand new. I mean, those mill marks look almost like they were done into this cast piece of aluminum, and they're not. So yeah, that one's a pretty new piece of casting, whereas this one is got some age on it. So yeah, if I get the light on, yeah, you can still see the mill marks in there. But yeah, every time you do a casting, the steel slightly wears a little bit, and so those mill marks slowly start wearing through. So you can still see them in there, but this one's got a little bit of age on it. There are some sprue marks in here, you know, where the molding went in, but still, this is pretty reasonable. There was silicone around this outside edge to seal that to here, you know, in here. So you know, it was pretty much waterproof in that regard. But at the same time, like, you can see all this junk in here. Yeah. That's, you know, basically imprecision, damage, whatever, to the casting that causes that. So otherwise, these wouldn't be here. This would be nice and smooth. They would be, well, like that. So this cast is gotten used a few times, and it's been damaged some bit because it's got some dents and cracks and, you know, little anomalies in it to create that stuff. Still a reasonably good casting. Here is the front cover. Grab that. And the outside looks pretty good, and the inside does too. But now you can't see any mill marks on here at all. And so this casting has been used a fair bit, and so all of those milling marks, like you see in there, because this is like a minty fresh cast mold made and then used pretty early on to make this piece. Whereas this one here has seen some use, and as a result, you don't see any mill marks anymore. They're all worn off. There's a little bit in here still, but not much. It's almost completely invisible. But still, it's a pretty decent casting. I like having like ribs inside here. Those reinforce this stuff, and this is obviously all machined, and again it was silicone down. I like the fact that there is a silicone seal in here, which you can see, so that rides on the shaft. So between this seal and the seal bearings, water incursion through the front and bearing failures are probably fairly minimal. I don't like this. Why didn't they put 3 of these screw studs 120 degrees apart? That way, this motor, which isn't very thick, you can literally bolt it down by this face and you're done. Instead, you've got to put 2 in this side and put a back bracket on it and bolt it down by the back side too. And for this thickness of a motor, that's not really necessary. They could have just done it right from here and it would have been A-okay. Anyway, yeah, the castings are reasonably good. This one is showing a little bit of age, but not too bad. This one is showing a little less age, but it's also got like that whatever goobers are in there in the casting. And this one here, you don't really see that inside there. So this casting has been used more, but it's also not seen any damage either. It's just, typical wear. Whereas this casting, yeah, that's how you get those goobers. Somebody was like beating on the thing with a hammer. I don't know. How do you make these little dents in there? But yeah, something was happening to this casting mold that would then transfer that to the liquid aluminum. And this one here, of course, is pretty brand new. Yeah, see mill marks on there. That means that's a brand new casting mold. And so, yeah, that's probably going to be the best precision of all these parts. Okay, all this stuff was held together by a couple different things. So the 2 end pieces, they were held on to here, and this is all threaded inside with M5. And so they were all threaded in with these screws, and as you can see, they've got Loctite on them. This is in the manufacturing process with screws. They just put a little blurb of it on there to hold those in. So yeah, the screws are long enough, and M5 is going to do the job, and there's 6 of them, I think it was, per side. Yeah, 6 of them per side. So it's probably enough to hold the end caps on without any trouble. And then, of course, the screws just basically keep the caps from rotating and snug down, and then they also have this internal lip right here. So once those 2 things press together, these caps aren't going anywhere. They're going to be a pretty snug fit. So don't have any problem with M5 screws, and there only being 6 of them. That's going to be pretty solid. The actual studs right here, so these are M6, and they each had an M6 nut on them, and they've got these little teeth on them so that when you lock them down, they tend to stay put. One of the oddities about that, and attention to detail here is a little strange. Where's the other one? There it is. So these are brass washers, and those were on the phases. Well, you can see this one is bigger, larger diameter, and it's also much thinner than the other ones. So why did they use 2 different size washers? Yeah, come on guys, use the same washer for everything. And truthfully, I'd rather have this larger, thinner one than these ones right here, because that gives the underside of these nuts something to purchase on, through those little teeth. And these ones here, you can see little marks in them, but they're just barely grabbing on those teeth on here. So these ones are too small, and this one has plenty of surface area for those teeth to bite into. So I would rather they use these ones, despite them being a little bit thinner. Really what I've liked to see is they use this diameter, but that thickness, because that's like 2 millimeters thick, and this is more like, I don't know, that's like 1.5, so maybe these thicker ones are like 2.5 millimeters thick. But use this diameter, but this thickness. Yeah, and there's 2 different nuts or washer sizes. Yeah, it's kind of weird. Yeah, I've already shown these, that hold that end cap on. Yeah, the screw heads being cammed out. Yeah, really, guys? That's, yeah, that's not cool. These wires, I'm going to have to pull off this insulation, the heat shrink on here. But yeah, the wire itself is not silicone. I'm not really worried about that. It's plenty flexible enough. It feels like it's 6-AUG, but there's no numbers on them that I can see on all 3 of the phase wires, so I can't really say. The heat shrink is not particularly tight. Like you can see that gap underneath there. And where's the green one? There we go. That one's really loose. Yeah, they didn't like run the hot air gun over it long enough to shrink the heat shrink down. And like this end here on this one, yeah, you can see that right there. So they basically put the heat shrink on there and didn't get it on the wire very good. So, good. Come on, guys. Fix that kind of stuff. You know, this is minor details. Costs you nothing to do a good job. And like right there, it looks like they used a pair of pliers on here for whatever reason, I don't know. But yeah, the heat shrink on there is completely buggered. It's got like plier marks, jaw marks in there. Yeah. The other phase wire, wherever it is, there it is. Yeah, this one is fairly good. You know, the heat shrink is totally shrunk down on both ends. And it doesn't look particularly buggered. Yeah, this one is fairly good, but you know, like this one here, you know, the heat shrink is got a big jink in it right there. Yeah, it's like, come on, guys, and like the wires skinned up. This came from the factory this way. It's a brand spanking new motor, so that's not super cool. On the signal cable, this part is all inside the motor, so I don't really care. And if this JST 2.5 connector, you know, you can see the silicone on there. It was secured in place, and you know, as long as this isn't going anywhere, it's not moving, I'm not worried about that. But this is a problem. That is never good. You want to put all of your small wires inside a connector that squeezes around the outer insulation here, because otherwise this is going to, like, after a while, it's going to break small strands. And, well, that's never good. So I will replace this entire thing with a whole nother cable. JST 2.5 is easy. I've got the whole crimp kit for all that stuff. But I will make a whole nother cable. At least they use Teflon wire. That's good. But my cable will have the outer insulation go all the way down to about that far from the ends of the wires. And then all those ends of those wires will then be secured inside the connector. So you will never have this kind of thing. And that way, these won't flex at all. They will be all inside the outer insulation, and there will be a silicone seal right here. So that the only thing that can move is everything outside, not inside like this. This should never be the case. And so this is, you know, meh, in my opinion. That's not very good. At least what they should have done is this heat shrink they put on here, they should have shoved it all the way up to here as much as they could have gotten, and that would have helped some. But still, I look at this kind of stuff and I think, yeah, not very good. Yeah, in this end of this cable, there are two wires right there, so they're brown and orange, and they're just cut off. Yeah, I don't know how they can show up on camera, but there's two strands there that don't do anything. So, you know, this cable here was for something else. I don't know. And yeah, they didn't need two strands. They just clip, and they probably did the same thing up here. Yeah, in fact, probably that little bulge in the heat shrink is probably one of them. Anyway, not super fond of this cable. Well, the next video I do on this thing will be inductance and resistance and magnetic strength. And then the one I do after that will be actually closing the motor up, spinning it up on a drill so we can look at the back EMF. And then after that, the motor will get used on something. I want to run it on the back 8000. I want to run it on the KO Pro controller. I want to run it on the EBMX X9000. I want to run it on the Tronic 750. Something else that's coming soon is, here is a brand spanking new Far Driver controller. So run it on there, you know, run it a whole bunch of stuff and show this motor in action. And so that's coming after a while. And also, I'm going to do the same thing for a QS138 once I have that one, and a QS180 once I have that one. I've got a hub motor that I'm going to run all that stuff against as well. Yeah, so you're going to see a bunch more testing around this stuff as time goes by. I will hopefully have a brake dyno after a while that I'm going to build, or somebody will build for me. I don't know which way that'll go. But that way I can actually load a motor up and show real live amperage draw on it. I'm going to use a VESC controller, specifically a Trampa 100-250. And VESC tool has some functionality in it for doing motor efficiency testing. So every single motor is also going to be on that VESC 100-250, so we can see actual losses. And that way it'll all be on the same controller, one controller, not several, and we can see all the losses across all the different kind of motors that I will possibly get in. Because motors do have internal losses. And so you want to have the one that has the least amount of losses to deal with. And those play out in how much power you get at the shaft. versus how much power you put in. People don't know this because they probably just basically dismissed the EBMX dyno runs. But you know, like on the KO motor that they, what is that, an R spec or something like that motor? Yeah, so that motor, they were running it for very brief amounts of time, and the power in versus the power out showed 7 kilowatts worth of losses. Yeah, some of that was in the controller, because everything has losses, but the vast majority of it was in this stuff right here in the motor. 7 kilowatts worth of losses. That's a lot of heat. Anyway, yeah, we're going to try to characterize all that stuff so that we can look at all these details and figure out what are good motors versus bad motors, you know, rather than people just doing butt dyno stuff. I want to be scientific. I like multiple points of truth. Anyway, I think that's it for this video. Hope you enjoy. There is more coming with this QS165. Take care, folks. Bye.